The disposal of trash has always been an issue. But what if I were to tell you it's not just trash on Earth that we need to be concerned with? There are almost 1 million pieces of human-made trash floating around the Earth. This space junk is everything from broken off pieces of rockets to inactive satellites. Satellites and space junk alike travel on orbits, which we can think of as highways that wrap around the Earth. These objects are traveling so fast on their space highways that they're like bullets. If one of these bullets happens to hit a satellite, this collision can create hundreds, if not thousands, of new debris objects. Because of this, the amount of space junk is growing faster than ever before. And if we don't stop this growth, our near-Earth space will become unusable. That means no missions to Mars and no GPS satellites to help us navigate. Since there's not a trash service in space yet, the most effective way for us to protect our ability to use space in the future is to prevent collisions. But this isn't easy, because much like here on Earth, there's weather in space. And if you thought the weatherman here on Earth was unreliable, well, space weather is far less predictable. Without any notice, the sun can send a storm our way, hitting Earth in a matter of hours or even minutes. If only we had access to better real-time information about space weather, we would be able to improve our models and prevent collisions by having our satellites take a detour around space junk. This is where I step in and throw a huge plot twist at you. What if we could use space junk to observe space weather? What do I mean by this? Well, you know how you're driving along and Google Maps alerts you that there's traffic ahead? It knows that there is traffic from the information it is gathering from each car individually. When several cars start to slow down on the same stretch of highway, Google Maps uses its algorithm to identify this as traffic. My vision is to do something similar in space with space junk. As space weather ramps up, space junk slows down, and we can observe their change in speed using telescopes. I'm developing an algorithm that uses space junk data collected by our telescopes in a whole new way. It identifies trends in the overall behavior of space junk to characterize space weather. My algorithm then applies this information to improve our space weather models. This new knowledge will prevent unnecessary collisions, expand our understanding of space weather, and help us navigate space, the future frontier. Thank you.